Seeking English S.A.T. Workbook, page 467, problem 1. A biologist projects that the population of a certain species of bird will increase by 20% every 5 years. If P, the letter P, represents the current population of the species, which of the following expressions represents the projected population of the species after T years? And these are the 4 answers. If you look at them, they have the P is the same in each case. That's really helpful. Only 2 things are different between these answers. So the 2 differences between the answers are this 0.2 versus this 1.2, and this 5t versus this t over 5. So if you get those 2 things right, you're done. Okay. What is the difference between these first 2 things? The growth rate is supposed to be 20%. Okay, and it's not the growth multiple. The growth multiple should be 100% plus 20%. That's 1.2. Okay, growth means that if you multiply the thing, a growth rate means that if you multiply the thing, you should be multiplying it, a positive number, by something larger than 1 in order to make it larger each time you multiply it. This number, because it is smaller than 1, will make p smaller each time you multiply it. That's the opposite direction in which you want to go. So again, you might look at my explanation of tax and discount, and I think the most recent video and some earlier videos. This is more like a tax. If you take a positive number, population is a positive number, and you multiply by a number larger than 1, it becomes larger. If you multiply it by a number smaller than 1, it becomes smaller. This number is smaller than 1. It's going the wrong way. I know I've explained it a lot. I just need to make sure it's absolutely obvious to you by the time you take the test exactly what I'm talking about here. Okay. The other thing that is, so these are correct, these are incorrect. The other difference is this 5t, I just do this right now, this 5t versus this t over 5, which is the same combination up here. So if the population were going to grow 20% every year, this t would represent 1 year. Okay? So the question is the population growing faster than that or slower than that? In the story it says every 5 years. That's slower. Which of these things represents slower growth? Well, whether it's obvious or not, maybe it is obvious. The larger exponent, okay, actually produces the greater growth rate because it causes this to be multiplied 5 times per year. This is the year, okay, multiplied by 5 as an exponent of this growth rate as applied to the p. Think about it. The larger the exponent is, the greater is the growth. So growth is greater, the growth is faster. Here, this shows every 5 years, and I know it's a little bit confusing. Do they grow abruptly? Is it no? It's the idea is it is like a continuous function, although I guess birds are units. This is a projected rate, so it does not need to be precise. Even so, between these, one answer is definitely wrong. That's this answer. This one might be imprecise in terms of projecting the results, but it's the better model between the 2 according to the way that the population growth is described. So if you had look at it this way, okay, this would be 1.2 to the 1/5. Okay, which is a pretty small number. Okay, there, multiplied by p would show the growth rate in 1 year, in a fractional year. That assumes that, okay, if you go any further than that, I know it gets off. Again, it's pretending that something is just basically a continuous curve, and populations don't really do that. I know. Okay, on the other hand, imagine you had, there, 5 years. It means this is equivalent to 1, so you would calculate this 1.2. Okay, 1.2 to the 1 is 1.2. So after 5 years, it would be p times 1.2. Okay, that's probably the simplest way of understanding this thing. Okay, I think I should probably stop now before I over-explain this thing. But the reason why I'm going on and on and on about it is that this is really not a very complex problem, and so if you've got some kind of a block about it, do not feel bad. When this finally clicks for you, it's going to be a pretty big click. This problem is foundational to other problems in the book, and it is very important to me that you understand what's going on in this problem. Certainly before the real test, and hopefully before you go on to related problems. Okay, if you're stuck with this problem, you're going to be stuck on top of stuck with problems that do essentially the same thing and something else. Okay, tell me in the comments section if you need some help. Tell me.